Okay, on this example number 4, what we have is a hanging bar that is connected by rod AB and rod CB, and at a distance of 1.5 meter. And it is given that the bar together with the rod, okay, the bar is, the rod is actually swing with a counterclockwise motion, and the omega, or the angular velocity, is given as 5 radian per second. Okay, and then at point B, okay, the bar is subjected to a 100 Newton horizontal force, okay, at point B. And the bar itself is, the mass of the bar is 100 kilogram, okay, and the center of mass for the bar is given and denoted as point G. Okay, to solve these particular problems, okay, as we need to determine the tension developed in the rod and the angular acceleration of the rod at this instant. First, we must know that there are two components of acceleration involved in these particular problems. One is the tangential acceleration, and the other one is the normal acceleration. For the tangential acceleration, it is just simply alpha times r. Okay, r is the distance of this. In this case, it is from A to B, which is 1.5 meter. Okay, and then for the normal acceleration, as we have learned before, that for the normal acceleration, it is equal to omega square times r. And the omega is given as 5 meter per second and square, and then multiply by the r. Again, it is 1.5 meter, and we have this answer. Okay, now we can solve this problem, and we look into the forces into the tangential and normal components. Okay, first we look into the tangential component, where we have 100 Newton horizontal force on this part, that, okay, pointing at point B, and that is equal to the mass of the bar, which is 50 kilograms, times the tangential acceleration of the bar. And we know that tangential acceleration of the bar is, like we have determined earlier, which is alpha, 1.5 alpha, okay, like that. Then we can solve for alpha, and it is like so, 1.33 radian per second square. Okay, moving on. For the normal force, the summation of normal force, what we have here is the tension. T is denoted TAB and TCD, the tension force. Okay, the tension AB and tension CD on each of these two rods. And then we know that this bar is actually have some weight on it because the mass is uh, here is 50 kilograms. Okay, the mass is 50 kilograms. Okay, now we know that the tension is pointing upwards in the positive direction, and the weight is pointing downwards, and therefore we have a minus sign on this part. And that's all equal to the mass of the bar multiplied by the normal acceleration of the bar, which is that what we have calculated earlier. And then from this, we can have one equation. We can name it as equation number 1. Then we can also calculate the summation of moment at point G. And uh, here we can assume that the counterclockwise motion is our positive direction. Okay, summation of moment at point G is equal to 0. Then we have the tension at CD, which is pointing upwards, and it will make that direction. And the distance is 1 meter, like so, 1 meter. And then we also have the tension at AB, which we know that this is our center of rotation. Force is pointing upward, we'll do like that, and it is our negative. I suppose negative because it is a clockwise direction. So you have a negative sign, and again the perpendicular distance is 1 meter, and that is equal to 0. Okay, and this is our equation number 2. So now we have 2 equations and 2 unknowns. Therefore, we can calculate the tension developed in the rods. Okay, that's all. Thank you very much.